Okay, hi everyone, welcome back to the Comptia Security Plus course. Removable storage. Removable storage or removable media includes optical discs, USB devices, eSATA devices, and even floppy disks in some cases. A network administrator can prevent access to removable media devices from within the BIOS and within the operating system policies. In many companies, all removable media is blocked except for specifically necessary devices which are approved on a case-by-case basis. Users should be trained on the proper usage of removable media and should not be allowed to take any data home with them. Users who sometimes work from home should do so via a virtual private network VPN connection to keep the data confidential yet accessible. USB devices must be carefully considered. They are small but can transport a lot of data. These devices can be the victim of attacks and can act as a delivery mechanism for attacks to a computer. For example, a USB flash drive might have data, files, or entire virtual operating systems that can be exploited by viruses and worms. Also, an attacker can install a special type of virus or worm onto the flash drive that is executed when the flash drive is connected to the computer. In this scenario, the computer is the target for the malware. Organizations must decide whether to allow USB devices to be used. Organizational policies should state that USB sticks should not be carried from one department to another without proper security procedures in place. Operating system group policies can be implemented to enforce which users are allowed to use USB devices. As mentioned earlier, the BIOS can also disable the use of USB devices on a local computer. Finally, data on a USB device can be encrypted with various programs, for example Windows BitLocker on the software side, or you might opt to purchase a secure flash drive such as one by IronKey. USB flash devices can easily be considered inherently insecure devices. It's the nature of the beast, so as to speak. As such, a security administrator needs to implement removable media controls governing the usage of USB sticks and other removable media. These should include, but are not limited to, USB lockdown in the BIOS and OS, limited to USB devices, scanning of media devices for malware, encryption of data, monitoring of connected systems, and auditing of removable media. In addition, the reuse and disposal of removable media should be carefully managed. Destruction of media might be necessary. Finally, a security administrator should be instrumental in writing policies for the company that dictate how these controls are implemented and educate users about the policies and maintain their awareness over time. If anyone's interested in the IronKey USB drive, the website is www.ironkey.com/ENUS. Network attached storage. Network attached storage (NAS) is a storage device that connects directly to your Ethernet network. Basic home and office NAS devices usually contain 2 hard drives, enabling you to set up RAID 1 mirroring, which protects your data if one drive fails. A more advanced example of NAS will be a device that looks more like a computer and might house up to 32 drives and contain terabytes of data. Possibly hot swappable, these drives can be physically replaced and the data can be rebuilt in a short amount of time. However, when it comes to RAID arrays, what we desire is high availability, meaning continuously operational for extended periods of time in the neighborhood of 99.9% average uptime or higher. An NAS device might be part of a larger storage area network (SAN) Therefore, a network security should also be considered when implementing any type of NAS. For more information on network security, protect NAS device, consider data encryption, authentication, constant secure logging of the device. Whole disk encryption. Encryption is a huge component of today's computer security. By encrypting information, the data is rearranged in such a way that only the persons with their proper authentication can read it. To encrypt an entire drive, you either need a self-encrypting drive (SED), or some kind of full disk encryption (FDE) software. Disk, though not accurate in some cases, is the commonly used term here. Several types of FDE software are currently available on the market. One developed by Microsoft is called BitLocker, available in the Elite edition of several newer versions of Windows. Full disk encryption can encrypt the entire disk, which after complete is transparent to the user. Following are some requirements for encrypting the entire drive. Trusted Platform Module (TPM), a chip residing on the motherboard that stores the encrypted keys. This is part of the concept mentioned previously, known as the root of trust. An external USB key to store the encrypted keys. A hard drive with 2 volumes, preferably created during the installation of Windows. One volume is for the operating system, most likely C, that will be encrypted. The other is the active volume that remains unencrypted so that the computer can boot. If a second volume needs to be created, the BitLocker drive preparation tool can be of assistance and can be downloaded from the Microsoft Download Center. BitLocker software is based on the Advanced Encryption Standard (AES) and can use 128-bit and 256-bit keys. Keep in mind that a drive encrypted with BitLocker usually suffers in performance compared to a non-encrypted drive and could have a shorter shelf life as well. In the appropriate Windows version edition, BitLocker security settings can be accessed via the following steps. Navigate to the run prompt, type gpedit and press enter. Step 3, in the group policy editor window, navigate to computer configuration, administrative templates, Windows components, BitLocker drive encryption. Although it can be a lot of work to implement, double encryption can be a very successful technique when it comes to securing files. For example, a hard drive encrypted with BitLocker could also use EFS to encrypt individual files. This way, files that are copied to external media will remain encrypted even though they don't reside on the drive, using whole disk encryption. Hardware security modules. Hardware security modules, HSMs, are physical devices that act as security crypto processors. This means that they are used for encryption during secure login authentication processes, during digital signing of data, and for payment security systems. The beauty of a hardware-based encryption device such as an HSM or a TPM is that it is faster than software encryption. HSMs can be found in adapter card form and devices that plug into a computer via USB. As network attached storage devices, they are generally tamper-proof, giving a high level of physical security. They can also be used in high availability clustered environments because they work independently of other computer systems and are used solely to calculate the data required for encryption keys. However, many of these devices require some kind of management software to be installed on the computer they are connected to. Some manufacturers offer this support as part of the purchase, but others do not, forcing the purchaser to build the management software themselves. Due to the lack of management software, the cost and the cost involved in general, HSMs have been slower deployment with some organizations. This concept also holds true for hardware-based drive encryption solutions. Securing wireless peripherals. In today's hassle-free world of peripherals, there are a ton of wireless devices in use, unfortunately, because wireless signals are generally spread spectrum. They can be more easily intercepted than wired signals. Some wireless peripherals, such as keyboards and mice, can have their keystrokes and clicks captured with the most basic of attacks. To protect against this, some manufacturers offer encrypted wireless device solutions, with AES being one of the most common encryption protocols used. Wireless displays use technologies such as Wi-Fi Direct WIDI. This is backward compatible with standard Wi-Fi technologies. As such, these displays should make connections using WPA2 and AES. Wi-Fi enabled cameras and micro SD cards should be configured in a similar manner. The same goes for external storage devices, printers and multifunctional devices. The bottom line is any peripheral that connects in a wireless fashion needs to have proper authentication put in place, such as WPA2, and strong encryption such as AES 256 or higher. Also keep in mind that newer types of authentication and encryption becomes available occasionally. Remember to periodically check whether your wireless security schemes are up to date. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.